Hi students, in this video we are going to solve problems related to complex number. The question is, find the modulus of 1 plus I divided by 1 minus I minus 1 minus I divided by 1 plus I. We can solve this in a two different way. One is we can simplify this fraction, this division, and then in this division, and then it can be subtracted. Otherwise we can do the cross multiplication, because when we do the cross multiplication the denominator becomes a real number, because 1 minus I and 1 plus I gives us 1 square minus I square. 1 square is 1, minus I square means minus 1 into minus 1 becomes plus 1, hence it becomes a real number 2. Hence we can do the cross multiplication. So when we do the cross multiplication, 1 plus I into 1 plus I gives us 1 plus I square, minus 1 minus I into 1 minus I gives us 1 minus I whole square, divided by 1 minus I and into 1 plus I. And when we do the simplification, what happens is we have to apply a plus b whole square, and then here a minus b whole square, and then this 1 minus I whole square should be subtracted from 1 plus I square. So 1 plus I whole square will give us a plus b whole square formulas, that is 1 square plus I square plus 2i. 1 square plus I square means here minus 1 and plus 1 will get cancelled, so 2i will be there, and then 1 minus I square means 1 square plus I square minus 2i. So 1 square minus I square will get cancelled. Finally when we simplify this term we will get this 4i, and here we have a minus b into a plus b, so a square minus b square, we know that I square value is minus 1, and then minus 1 is multiplied with this minus 1, it becomes plus 1, hence 1 plus 1 gives us 2, and in the numerator we have 4i. 2 and 4 can be cancelled and it will become 2i. Actually we need to find out the modulus of this function. In order to find the modulus of this number, it has to be written in the standard form. This 2i can be written as 0 plus 2i. So modulus of z value we know, that is the square root of real part of z whole square plus imaginary part of whole square. So modulus of z is equal to square root of, here real part is 0 plus imaginary part is 2 square, which is equal to square root of 4, which is 2. I hope you can understand this problem. Now we move on to next question, and this one is z1 is equal to 1 minus I and z2 is equal to minus 2 plus 4i. Find imaginary part of z1 into z2 divided by z1 bar. First what we need to do is we need to multiply z1 and z2, and the final value of that multiplication should be divided by conjugate of z1, and then we have to find out the imaginary part of that expression. So z1 into z2 means, you know that 1 minus I into minus 2 plus 4i whole divided by z1 bar. Here we need to find out conjugate of z1. Conjugate of z1 means we will change the sign of imaginary part. Here sign of imaginary part is minus, it will be converted as plus, so 1 plus I. Now we need to multiply the numerator complex numbers. So 1 has to be taken like algebraic multiplication. 1 into minus 2 minus 2, 1 into 4i is plus 4i, it is given here, and then minus I into minus 2 minus plus 2i, plus 2i is given here, and then this minus I is multiplied with plus 4i, we get minus 4i square. Minus 4i square, I square is minus 1, so minus 1 minus 4, it gives us plus 4, it can be seen here. So when we simplify it we get 2 plus 6i. You just work on this step on your own. You just do the polynomial algebraic multiplication, and then you will get the final answer of 2 plus 6i, and in the denominator we have 1 plus I. I already told you, in the denominator if we have complex number we will try to convert them into real number by multiplying numerator and denominator by its conjugate. Conjugate of 1 plus I is 1 minus I, hence numerator and denominator is multiplied by 1 minus I. You know how to do the multiplication of the numerator. In the denominator we will have we have a plus b into a minus b, so a square minus b square formula. I square is minus 1, minus 1 into minus will give us plus 1, so plus 1 into plus 1 will give us 2. When we do the numerator multiplication, we get 8 plus 4i. Here 4 can be taken as common and then 2 can be cancelled. We will get this final answer. So after doing z1 into z2 divided by modulus of divided by conjugate of z1 gives us 4 plus 2i, in which we need to find imaginary part value is plus 2. I hope you understand this problem. Now we move on to next question. The next question is, find the least positive integral value of m for which 1 plus I divided by 1 minus I whole power m is equal to 1. First, what we need to do is we need to do this division, and the final resultant value should be raised to the power m, so that the expression value is equal to 1. Then we need to find out for what value of m the division value, final result value is equal to 1. So first we need to do the division. In order to do the division, first we must check the denominator. In the denominator we have complex number. It has to be converted into real number by multiplying numerator and denominator by its conjugate. So we will multiply this 1 plus I divided by 1 minus I by the number 1 plus I. So we get, you observe it, we are multiplying numerator and denominator by the denominator's conjugate. In the numerator now we get 1 plus I whole square. In the denominator we have a minus b into a plus b, hence a square minus b square formula. In the numerator we have a plus b whole square, so a square plus b square plus 2ab divided by 1 square. This value I square value is minus 1, that minus 1 is multiplied by this minus, so we get plus 1 and 1 gives us 2. Now we know I square value is minus 1, hence minus 1 plus 1 will become 0. We will have 2i divided by 2. When we cancel it, we get I. So we did the division in which we got the number I. It can be converted in the form I power m, right? This is equal to I power m. In this place we can substitute I power m is equal to 1, means we know that if I power 4, actually here we need to find least positive integral, least value as well as positive integral value. I power 4 value is equal to 1, hence m value is equal to 4. I hope you understand this problem as well. Now we move on to next question. The next question is, find the values of x and y if 2 plus x plus iy is equal to 3 minus iy. What we need to do is just we need to simplify it and then equate it. 2 plus x, here x is a real part will be added with real part, so 2 plus x plus iota times of y is equal to 3 minus iy. When two complex numbers are equal, we know that real part must be equal to real part, imaginary part should be equal to imaginary part. Hence 2 plus x should be equal to 3 and y value is equal to minus 1. So from which x value can be calculated as 1, y value as minus 1. Similarly, we can solve the next problem. Here x plus 4 iy is equal to ix plus y plus 3. Two complex numbers are equal when their real part and imaginary parts are equal. Here in the left hand side real part is x, in the right hand side real part is y plus 3. Hence x is equal to y plus 3, and in the left hand side imaginary part is plus 4y and in the right side imaginary part is x. Hence we can say 4y is equal to x. That you can see it. Now we need to find out x and y value. Here we have linear equation in two variables. Here also we have linear equation in two variables. Then we can solve it. What we can do is, in the first equation, in place of x we can substitute 4y. Substitution technique can be applied. When we solve it, we get the final answer of x is equal to 4 and y is equal to 1. I hope you understand these problems clearly. In the next video we will see some more problems related to it. Thank you students. Thanks for your cooperation.